Hello friends, welcome to my channel PH Chemistry. So in this video we are going to talk about Friedel-Crafts acylation. In last video we have seen Friedel-Crafts alkylation. If you missed that video, I'll provide you the link in the description because this is somewhat similar to Friedel-Crafts alkylation. So in this video we are going to see the reaction of this, mechanism of this, some examples related to this reaction, and lastly we'll see the tricks. First, do watch the Friedel-Crafts alkylation reaction. I'll provide you the link in the description. I'll write one very simple example of Friedel-Crafts alkylation. Here also benzene ring react with a acyl group. Anhydrous AlCl3 is used as in the alkylation, and the product is this. Now we'll understand the mechanism of this reaction. First, this acyl chloride react with AlCl3. As I told you, AlCl3 is very deficient. This is a Lewis acid and this chlorine contains lone pair here. So this chlorine will give lone pair to AlCl3. So what will form is this AlCl3 gets attached to chlorine and this chlorine is attached to this group. Now chlorine is attached by two bonds, so the positive charge here, and aluminium is attached to four, so negative charge is here. Now this oxygen also contains lone pairs, so it will shift its lone pair towards here and this group will remove. So what will form is AlCl4 negative and this oxygen attached to triple bond to this 1 2 3. This is the, if we number it like 1 2 3, it will 1 2 3 positive charge. So this is this electrophile is formed. This is known as acylinium ion. This acylinium ion is formed as an electrophile in this reaction. In the second step, when this acylinium ion attacks on the benzene ring, this contain positive charge. So now this benzene ring attack to this carbon and this bond will restore. So the product form is like this. This double bonds get attached to this carbon number. If we number it like 1 2 3, it is attached to double bond now. This is 1 2 and 3 and positive charge will comes here. As I told you in the last lecture, this positive charge will move throughout the ring, as this double bond will transfer here, then this double bond will transfer here. So this positive charge will move throughout the ring, and in the last step what will happen, the hydrogen present here will be taken by AlCl4 negative. As this hydrogen removed, so negative charge forms here, positive negative will forms bond. So the product is, this is our final product. As I told you in the last lecture also, why we use anhydrous AlCl3, why we can't use a hydrated AlCl3. This is because AlCl3 is a Lewis acid. It is very deficient. So if the hydrated version is used, so this water will contain oxygen and oxygen is having two lone pairs. This AlCl3 will takes the lone pair from this oxygen only. It will not form electrophile with this acyl chloride. this is why the anhydrous AlCl3 is used in this reaction. Now we'll see some examples of it. So these are some examples which we are going to see. The first example is when the benzene ring react with this type of acyl group in presence of anhydrous AlCl3, what will form? Simply remove HCl. The product is like this. This is also known as benzophenone. The name of this product is benzophenone and HCl will remove. This hydrogen with this chlorine will remove from here and hydrogen from this ring will remove. This will directly attach to this benzene ring. So the product is benzophenone. Where this acyl group will attack. As I told you in the last lecture, it this chlorine contains lone pair. It will show plus R effect, means plus resonance effect. So the electron density is maximum at ortho and para position. So mixture of product is obtained. First product is ortho product and the second product is para product. So which will be major in this reaction? The major will be the para because of the Lase hindrance and minor will be ortho because of the Mohr hindrance. The name of this product is para-chloroacetophenone. Why para-chloroacetophenone? Because at para position chlorine is present and this benzene ring attached to C double bond or CH3 is known as acetophenone. And this is orthochloroacetophenone. I took a general example of anhydride. This is aliphatic anhydride. When this react with benzene in presence of AlCl3, the product will form is simply this, because this will detach from here, the electrophile forms here and this acid will remove hydrogen from the benzene ring and this whole group will remove. So this is the byproduct in this reaction and this is the main product. So how the mechanism goes for this reaction, I'll show you. So this is the reaction. When this anhydride react with the AlCl3, which is Lewis acid very deficient, this oxygen contains lone pairs of electron. So this will attack on this AlCl3. So here oxygen gets attached to this AlCl3. Oxygen contains now positive charge, AlCl3 contains negative charge. Here also this oxygen contains lone pair, this oxygen also contains lone pair. So this lone pairs will shift here, this double bond will shift here and this is restored. So now this R gets attached to the oxygen by triple bond plus, you can see this R is attached to this carbon. This carbon is attached by the single bond to AlCl3 and this carbon forms a double bond with oxygen. So this is our acylium ion, which is the electrophile in this reaction. Now this acylium ion reacts with a benzene ring. This benzene ring will attack on this carbon. This bond will restore. So what will form is double bond O bond, or this positive charge will rotate all over the ring and finally the hydrogen from here will remove. So the product is like this is our final product. So like this the mechanism will occur. This is the last example. This is also anhydride, but this is a cyclic anhydride. The former was the aliphatic anhydride. This is cyclic anhydride. When this react with the benzene ring, so the product is like this. This cyclic ring gets open up and attached to this benzene ring. So how the mechanism will takes place? In the first step, this anhydride will react with AlCl3. As AlCl3 is Lewis acid which is deficient, this oxygen contains lone pair. So this oxygen will give its lone pair to AlCl3, and what will form is like this oxygen gets attached to AlCl3, negative charge comes here and positive charge will come here. This double bond will shift here and this double bond will try to restore itself. So now this ring gets open as this double bond will break. So we'll get is this double bond now becomes single bond which is attached to AlCl3. AlCl3 having negative charge because attached to 4 different atoms. This single bonds now becomes double bond. This bond is broken, so positive charge will comes here. This is now our electrophile. Now this electrophile attacks on the benzene ring. Here is the benzene ring. Now what happens? This double bond will attacks here. So we'll get this benzene ring, positive charge here will attach to double bond, 2 carbons, and again double bond O AlCl3. This is negative. Again the hydrogen from here will be taken by this. So the product form is AlCl3 minus. Now acidic workup, we'll get this type of product. This is our final product with the acidic workup. So in this way the mechanism goes for this reaction. So this is it for today. I'll meet you in the next video. Till then, if you have any question you can ask in the comment box, and do subscribe my channel. Thank you so much.